All right, guys. Well, I'm flying solo today on the PowerPoint. So, anyways, hey, this is chapter 10.2 of circles, and this is going to be with finding the measurements of arcs and central angles. And so, really, there's two types of arcs we're really going to look at when we talk about arcs, and we've kind of already done some of this when we were doing things with area in chapter 11, I believe, when we were looking at area of a sector and the measurement of an arc. So some of this stuff should be review for you. Some of it may be new, but anyways. So when we talk about minor arcs, that's the first type there in the blue. Minor arcs are any arcs along a circle that are less than 180 degrees. And when we label an arc that's less than 180 degrees, we label it with 2 points. The 2 points on the slide there, guys, doesn't mean you get 2 points for answering it correctly. It means you'll use 2 points when you're going to label it. Okay, and then for a major arc is anything that's greater than 180 degrees. And when we label an arc that's greater than 180 degrees, we want to use 3 points. And we'll talk about this here a little bit. If you look down at the bottom, the minor arc in red there is arc AB, and because it is less than 90 degrees, or excuse me, it is less than 180 degrees, we're going to use 2 points AB to label that with the little curve on the top. And then if we were to look at from A around through D all the way to B, that would be definitely more than 180 degrees, because if I go through A all the way to D and then through B, you can see that that's more than 180 degrees of the circle, so I would call that major arc ADB. Now, you don't have to write the word minor and major every time you write these, but if you show it with 2 points with the arc on top of it, we're going to know you're talking about something less than 180 degrees. If we say a major arc, then we're going to see an arc with 3 points in it, or an arc could also be, as you see in the red there up back at the top, diameters create semicircles that equal 180 degrees, and we also label those in 3 points. So anything really 3 points or 180 degrees or greater, we always want to label that using 3 points. So if we were to say that from A all the way to D was a diameter, okay, if we drew a segment from A straight over to D on that drawing down there below, we would want to label that arc ABD to label that diameter, because we want to use 3 points to label it in. And so the last thing on here is the measurement of an arc equals its central angle. So what that means there is, if I look at arc AB, all right, the red arc down there on that circle, if I said that that arc was 30 degrees, then the angle ACB, which is a central angle starts from the center of the circle out to 2 points on the outside. That's a central angle. If that measurement of arc AB is 30, then the angle ACB would also be 30 degrees. Okay? So here's some practice of this. All right, so we're going to look at arc RS. And so if we look at arc RS up there on the right, we see that angle RPS is 110 degrees. So that central angle of RPS, if that central angle is 110 degrees, then arc RS would also be 110 degrees. Now this is important, and you guys got to make sure that you don't think that any angle in there will always equal the arc outside of it. Okay, there's central angles, and then we're going to talk about something that's called an inscribed angle. Okay, so you got to be really careful here. But for the central angles, they always equal their arcs on the outside. So if we look at RTS, okay, arc RTS, all right, so that means we want to go from R over to T to S. So you got to make sure that you go counterclockwise here. If we want to figure out that arc, all right, well, you know, you're going to have to do a little bit of math here. So we know that from R to S is 110 degrees. So from R to T to S, if we just went 360, because there's 360 degrees around a circle, subtract that 110, then we're going to be left over, okay, with 250 degrees. Now, there's another way you could do this. You could go and say, okay, from R all the way over to T is 180 degrees, because that's half a circle. And then if on the other, so if 180 minus 110 would be 70, and 180 plus 70 also equals 250. So that's another way you can go about doing that. Okay? But sometimes it's easier to subtract and get the answer, or sometimes it's easier to add and get the answer. You're just going to have to decide that for yourself. So now if we look at arc RST, okay, arc RST, all right, so now that's just a diameter, so that's going to make that one 180 degrees. Okay? So anyways, central angles, arcs, kind of important thing here. Let's continue to move forward here. So now, the arc addition postulate. Hey, addition postulate, back again. Remember, we've had segment addition postulate. We've had we've been able to combine shapes to make an addition postulate. We've been able to do segment addition postulate. We've been able to do, what's the other one? I can't think of it right now. But we do arc addition postulate, where we do addition postulates all the time, guys. So, anyways, postulate 23 means you can add adjacent arcs together. So if you had a 30-degree arc and then a 40-degree arc right next to it, that makes a 70-degree arc from the start to the finish. So, real easy idea. You'll catch on to that pretty quick. And then it says congruent circles and congruent arcs. All right. So in order for two circles to be congruent, they need to have this, and two arcs to be congruent, they need to have the same measure and the same radius. So if we look at this here, tell whether the red arcs are congruent and explain why or why not. All right. So if we look at this here, all right, for those first two there, the triangle, the circle here on the left and the circle here on the right. Okay, if we want to know if those arcs are congruent, well, first of all, we know that those radiuses there are congruent. And since the central angle on each of them is 145 degrees, then that means that those arcs are the same. And so it meets both those criteria. It means that the measurement of the arc is the same and the radius in that arc is also the same. So that first set would be congruent. Now, if you look at the second one, you can clearly see, just by common sense, okay, that those arcs are not the same length. Okay? So now, explain why or why not here. If you look from the center of that circle to the small circle on the inside, that radius is a lot shorter than it is. From the center to S is a lot shorter than from the center out to U. And so the arcs may still be 90 degrees in degrees, but their actual measure, if you were to walk those steps from T to U or from R to S, you would definitely be able to see a difference in their actual length, okay, because they don't share the same length and radius. All right? All right, so for the first one, yes, the angles are congruent and the radiuses are congruent. And then the second one is no, because they have different radii. All right?